Okay, so now that we've learned the evidence that supports the theory that our continents move, and we've learned about the inside of the Earth and how the mantle creates those movements, we're going to start to learn about how what happens when our continents move. So this is a cute little comment. When the continents move, come on Rex, you can do it. Jump boy, jump. Hurry Rex, hurry. Thought I'd have to show you that. Continents don't move that fast, but that was cute. This is also a picture that shows you. Whoops, there goes our bell. It shows you a picture of how the continents have moved over time. So they start, excuse me, 225 million years ago, Pangea, when the continents were together, they started to separate in the Triassic, Jurassic, Cretaceous, and then we have present day. So you can see it takes a really long time for our continents to move. They only move about 1 to 2 centimeters a year. So that's why it takes millions of years for there to be any noticeable difference in our continent movement. Okay. All right, so today our essential question is, how does the movement of plates affect life on Earth? So now we're going to talk about how when our continents move, what happens on the surface of Earth. So this goes with learning targets 23 and 24. Learning target 23, you will be able to identify, interpret, and explain and models of plate motions on Earth and how they cause major geological events. So you're going to be able to determine, okay, when plates move this way, volcanoes form. When plates move this way, earthquakes form. You're also okay, sorry, small interruption. Okay, so learning target 23, 24, you will be looking at maps and locating areas on Earth where volcanoes occur, earthquakes, mountain buildings. So you're going to be looking at the data and making connections and patterns using that data to figure out where our earthquakes and volcanoes are likely to occur. So those are our learning targets for this lesson. Okay, so Alfred Wegener was able to say that the continents move, and he was able to give evidence that our continents move, but he didn't know why. And that's when we started to study what's inside the Earth, and we learned about the mantle and the amphosphere, that was the liquid part of the mantle that has those convection currents. We were able to prove that yes, continents do move, and here is why. So it's now called the theory of plate tectonics. So the theory of plate tectonics combined continental drift and seafloor spreading theories. Those are what Alfred Wegener was starting with, his continental drift theory. And basically, the theory of plate tectonics states that the Earth's crust and the part of the upper mantle, that rigid part of the mantle, so this is our lithosphere. So I'm talking about right now our lithosphere. Okay, so the Earth's crust and the upper part of the mantle, and I misspelled mantle, I apologize, that is our lithosphere, are broken into sections, which we are going to call plates, hence the name plate tectonics, that move on the layer of the mantle. That's what's underneath the rigid part of the mantle, the amphosphere. Okay, so you kind of think about it as rafts that float and move on a mantle. That's what our crust does, and it's broken up into pieces, which we call plates. So when we look at those plates, we're going to look at plate boundaries. Plate boundaries are where plates are meeting, are next to each other. And just so you guys know, there's not gaps between plates. They're moving different ways, but they're next to each other. So there's 3 different types of plate boundaries, 3 different ways that these big plates move. The first way that they move is called convergent. Okay, convergent boundaries are when plates collide or come together. Now, when we look at convergent boundaries, that's where we're going to talk about what forms on the Earth's surface. So we're going to look at a couple different ways that convergent boundaries occur. We're going to look at oceanic crust colliding with continental crust first. So remember, our crust is either 2 types, oceanic or continental. So when oceanic crust collides with continental crust, 2 things form. We have what's called a trench and a volcano. So let me pull these up and I will oh, my internet connection is not working. That's not. Okay, so when an oceanic plate and the continental plate collide. The oceanic plate, remember, is thicker, it's heavier. It has the ocean on top of it. So what it does is the oceanic plate actually subducts underneath the continental plate. So that's what I'm going to show you right now. So the oceanic plate is going to subduct underneath. And then you have heat and pressure in the mantle squeeze water out of the subducting plate. It also squeezes magma. Okay, the mantle material melts, so the part of the oceanic crust, which is made up of rock, it melts, turns into magma. Then the magma is pushed up through the crust and forms a magma chamber. And I bet you can guess what's going to happen. Then a lot of pressure is going to propel that lava up, and we're going to have volcanoes on the continent. So whenever you have an oceanic plate and a continental plate colliding, the continental plate will have volcanoes. Once the magma is okay. Okay, so that's what happens when we have continental and oceanic crust colliding. Volcanoes form. Okay, so volcanoes form because the rock in the oceanic crust gets put under immense heat and pressure, and it turns it into magma that creates pressure, and you get volcanoes just like this. Now, the area where the oceanic plate is going underneath the continental plate creates a depression called a trench. So that's why trenches also form when you have oceanic crust colliding with the continental crust. So two things happen on the Earth's surface. Volcanoes form, and then in the ocean a trench forms. Okay, to show you a picture. All right, here's our oceanic plate subducting, going underneath the continental plate. The area where it's going underneath the continental plate creates that little depression called the trench, and this is in the ocean. The largest trench that we have here on Earth is the Mariana Trench. That actually occurs where the Pacific plate is hitting the Asian plate. Then on the continent, look, we've got our crust, and our oceanic plate is put under a lot of temperature and pressure and melts, turns into magma, and creates those volcanic mountains. So that's what happens when oceanic and continental plates collide. Now, when just oceanic and oceanic plates collide, a trench or a depression will form. Okay, simply because both the oceanic plates are dense and heavy, so they're both going to hit each other and sink below each other, and that's going to create that trench. Now, when you have a continental and continental plate, oh, here's my picture for the oceanic, right there. There's your trench. Okay, when a continental plate hits another continental plate, we just have mountain ranges forming. This is how our Himalaya mountain range formed. When that plate collided with Europe, they were both continental plates, they created the Himalaya mountain ranges. So that's what this is showing you right here. Okay, there's my, I think I lost one of my words. Okay, the next type of boundary is what we call, I'm going to type it in, a divergent boundary. A divergent boundary, plates pull apart, separate. Okay, so divergent boundaries are when plates are pulling apart. Plates will pull apart, and when you have a continental and a continental plate pulling apart, you have just a valley forming right here. Okay, so two continental plates form, you get a depression in the Earth's surface, and we call that a rift valley. Okay, so when two continental plates pull apart, you form a rift valley. When two oceanic plates pull apart, a lot of things form. You get what's called new seafloor or new crust, new oceanic crust, and it's called a mid-oceanic ridge. Okay, and I'm going to show you a video of that so you can see what that looks like. When it loads. Oh, I lost that link. Never mind. Just kidding. Okay, but I have a picture. So here's the picture right here. So when we have two oceanic plates pulling apart, this is our seafloor spreading that we mentioned earlier. Okay, magma will rise up through cracks in the crust, hit the water, cool and harden, and that magma will transform and change into igneous rocks. So we actually get more rock being formed when oceanic plates are pulling apart. And those rocks create like little ridges, like small underwater mountains. So when two oceanic plates pull apart, we have new oceanic crust that's forming. Now the last type of boundary, and I seem to erase these, the last type of boundary is your transform boundary. A transform boundary is where two plates slide past each other. Okay, when this happens, you get one thing that occurs, and that's your earthquake. Okay, so your earthquake forms when anytime two plates slide past each other. If it's underwater, if it's oceanic plates that are sliding past each other, you get what's called a tsunami. So that's an earthquake that occurs underwater. Okay, and this is what it looks like when two plates are sliding past each other. Okay, so one thing we need to make sure that we remember, and we've talked about this theory a lot when we talked about cells, photosynthesis, and cellular respiration, the theory of conservation of matter, where matter cannot be created or destroyed, it can only change. When plates collide, diverge, or transform, whichever one of those that they do, okay, because remember they can do three things. They can come together, they can pull apart, or they can slide past. The rock in the crust, it's not created or destroyed, it's just changed. Okay, so for example, when the oceanic plate subducts underneath the continental plate, the oceanic crust is not destroyed, it's just changed into magma. So if we look back over here, when the oceanic plate starts to subduct, the material in the oceanic plate starts to melt. So it just goes from a rock back into magma. So we're not destroying matter, all we're doing is changing it from a solid to a liquid. So that the plate tectonics also supports our theory of conservation of matter. Okay, so that concludes our notes on how the three different ways that plates move and how they can affect the surface of our Earth.